Welcome to Python video on lists. We're going to talk about lists and you'll see that they are very powerful. So we're going to talk about sequences, lists, slicing of lists, and how do we get parts of the list, and then finding items in the list with in operator, which is so easy to use, and then list methods and some of the useful built-in functions for a list. Okay. So the sequence is basically an object that contains multiple items of data. Okay, it could be an array, it could be a collection. So in Java, you have these sequences called collections. You have arrays, of course, but there are also lists. Okay, so here as well, we have these sequences. So the items are stored in a sequence of one after another. So if you think about from our chapter 8, we talked about generators, and generators are just like that too. They are also sequences. Okay. So there are different types of sequences. Tuples are one of them, lists are another one, and we'll talk about differences of these as well. A simple difference between a tuple and a list is mutable. That means you can change each element, but a tuple is immutable, so that means you cannot change its elements. So we kind of talked about this at the very beginning of the course. So list basically is designated by a square bracket at the beginning and at the end. In between, you have basically a bunch of things. You can have anything in that list. Okay, so it could be heterogeneous, it could be homogeneous. Okay, and there is a print function that can use to print the entire list, and of course, there is a list function that can take any sequence and turn it into a list. Okay, right. So the lists are just like arrays in Java. So you can basically have a list of, integers, strings, or a mixture of different types. Okay, so we call these heterogeneous lists. Okay. And indexing just like works with arrays, it starts from 0 and it goes. And you also have negative elements. So if you have a list, okay, so let's make this like this. So the first element in the list, you can think of these as boxes. Okay, so the first element is 0, 1, and 2. And if you do it the reverse, you actually have -1, -2, so it goes in the reverse order. So we're going to do some examples of this. Okay, so of course the reverse order is this way. Okay, so in this case this goes 3, 3, 4, and 5. So and then again it goes all the way to right. So -6. Okay, so notice there is no -0, so it starts from -1. So you can do the reverse as well. Alright, so let's do an example quickly. Alright, so I have a bunch of files open. So here's a collection. The collection is a list. So I'm going to go ahead and run this. And here I'm printing each element. So let me also print. Finally, I'm just going to go ahead and print the last element. Right. So the last element, I want to print it again. This time I'm going to print it with -1. Right, so let's go ahead and run this. So here is the list. So this is starting from all the way to the positive indexes, 0 all the way to 6. And -1, you notice it also gets us the last element, which is this one. Okay. So if you go ahead and print -2, it will be the second element from the last. Okay. Right, so right there, 0.03. And you can also print the whole thing. Okay. So you notice it says built-in function print. So actually you can put functions into a list as well. In this list, we have a float, we have an integer, we have a string, we have a function, we have again another integer, and there is a negative float number, and then finally another string. So this is kind of a collection. And remember, this collection is a class that's available in Java as well. Okay, but here in Python, it's built-in. So lists are built-in functions. You don't have to import anything. They're just inside the Python. All right, so this is the negative indexes. So you can access these elements. We talked about this. So here 0, 1, 2. And you can also do some basic operators on the list. Okay, you can print the whole list. You can use the name of the list to print. You can set an element. So this is basically so this is in this list LST, the first element is 2. You can replace this. Okay. Why? Because each element in the list refers to some memory location. You can actually make them refer to different memory location. Okay. So because of this, now you can set it equal to 5 because this is mutable. If this was a tuple, meaning that these were not square brackets but they were just parentheses, in this case, and that LST could have been a tuple, that could not be mutable. Okay. All right. So negative indexes, we talked about this. All right. You can have an heterogeneous list, just we talked about this. And what you can do with these heterogeneous lists is very nice. So you can actually traverse the list. So let's go ahead and do this with that example. It's a very nice example actually, which will help us quite a bit. So what you can do here is, I'm going to go ahead and get rid of these. For now, let me just get rid of all of this. And let me go comment them out. Right, so let's comment the whole region. So what you can do is you can go through this entire list. I in collection. All right. All right, so let me change the position of my keyboard. And then you can go ahead and say print I. So what this will do is, this will of course print each element of your list. Okay, so this is how you traverse. If you want, you can use a function called reverse. And what it will do is it will reverse the collection in memory. It's not going to change the actual list, but it will do it in the memory. So now it will give you a way to traverse the list in the reverse order. Okay? Right? So you're just doing it in the reverse order. Clearly, you can also traverse this list in reverse order using many different ways. You can look at the size of the list and then go in the reverse order that way as well. Okay? So, but this function is right there available and it's much easier to use. Now, what if you want to only print certain types? Remember, collection can have various types. What if you want to only print certain types? What you can do is you can actually put a condition. You can actually say reverse the list, traverse the list, go through the entire list, collection, but only print if, let's say, type of this variable that you're looking at, okay, is, let's say, integer, okay. So what this will do is it's going to only print if the type of I is an integer. Okay, so let's go ahead and run this. So you notice I have two integers in this list, 4 and 19. So if you want it to be string, you just say str. Okay. And you notice now it says toString. So that means you can actually select subtype of the string. And later on, I'm going to show you how you can do this with data frames in the pandas library, and you'll see that it will be very powerful. So alternatively, if you want more than one, you can actually create a list. You can actually say, let's say, you can, instead of is, you can just say in, use the in keyword, and put a list of types. You can say integer and string. Okay. All right, so now it's going to actually check the type to see if it's an integer or string. It's going to go ahead and print. So you can actually have a combination. Here you can actually do this. You can say else print. You can say I, and then say is not an integer or a string. Okay, so you can do this as well. Okay, so what it will do is it will print the integer, and it's going to actually tell you 24.42 is not an integer or a string, and so on. Okay, so let's fix this. All right, so you can actually do it in many different ways. So this type checking is very powerful. All right, so let's continue. So right, so we talked about this. You can actually have a sequence. You can create a sequence, and sequence can have different types in it. So it can be a list. Here is a list of one element, and then here is a string. So this is a list, and this is also a list. Okay, all right, and then you can actually create a sequence, and that will basically have all the elements. All right, so you can define this. Let me do it right here. I'm going to just do it right here. Let me quickly restart the shell. Right, so let me get rid of this. So let's do it right here. So we can define X to be a list of 5, okay, just one element. And we can define Y to be ABC as a string, and then let's define Z as a list of X and Y. Right? And then we can define a sequence, which is another list, which basically includes X, Y, and Z. Right? So let's print this sequence. Right? So you see now it's actually a list, a string, and a list of lists. So this is actually a list of 2 lists. Okay. So you can choose to set any of these variables. So you can actually set X equal to 0, X0, first element is equal to 0, and you'll notice now. Okay. So now if you print sequence again, you'll see that the first element will change. Everywhere it referred. So everywhere this X list is referred, the value will change. Okay? So keep that in mind, because these are reference types. However, if we change Y, so let's change Y. Let's say XXX. Right? So now let's look at the sequence again. You'll see now Y will not change. So the Y, since it was not a reference type, it was a value type, it's copied into the sequences, both Z and SEQ. Okay. So, but X was a reference type, so that means it's mutable, so it will be muted across all the lists where it's referred to. Okay, so keep that in mind, this is very critical. Now, internally, when you do use these lists, what is happening is actually you're using these built-in functions. So there is a set item when you update a list, and there is also a get item. These are methods of the list class. Okay. So you can actually call them directly if you want. You can actually write it in the sequence, and this will work. This is the exact same thing. It will give you the exact same thing. Now, you can actually repeat a list. So you can actually take a list and multiply it with an integer. Okay. So we talked about that. So this is very nice for setting up lists. Suppose you have a list and you want to actually set all elements equal to a certain value. You can actually do it with this. So traversals, forward and reverse, we actually did them already. Okay. So one way to do it is use the for loop, or you can actually look at the size or the length of the list. This is another option. Okay. So you can actually use those functions. This is really not necessary unless you know you're going to go to a certain portion of the list. You don't really need this. Okay. So both are equivalent. So the length function is going to give you the size, and if you traverse the list without the length function using a range, you may actually have an exception, index error exception. So it's always a good idea to use the size, the length function, so that you can find the size. You can element. So otherwise you can just do this for loop. So if you do this for loop at the top, you really don't have an issue of running out of the list indexes. But if you do this range, you have to make sure that the range is limited to the size of the list. So that's all. Backward traversal, as we said, is possible using this function, reverse function. So the reverse function is actually a static function of the list class. So you really don't need an instance. So it's a class function. So it's a static function. So it means you can actually use it with any list object. Okay. There is also another function called reverse function. This is not a static function. This is a member function. So that means you have to have a list element, LST, and then use it as. So what this will do is modify the list. So what this does is it modifies the original list, but this does not. Okay, so there is that difference. Okay, so there is reverse and reversed. Okay, one is a member function, and the other one is a static class function. The way that you use them are different. So we talked about mutability of the list. They are mutable, so you can concatenate the list. You can actually have two lists and add them. You can also use augmented operation. But there is one key here. When you augment an element to a list, it has to be a list. Otherwise, it will give you an error. Okay. So here are some examples. You can have a list 2468, and then you can actually add these, odd numbers to that list. All you have to do is just make sure that this has to be a list. Okay. So now A becomes all the elements, but in that order. So the lists do have an order, so that order is important. And you can also add individual elements, but if you try to do this, this is going to give you an error. This has to be in a list. So what is missing there is you are missing these. Okay, so you need to use square brackets so that you can add them. Right? And then you cannot concatenate. Sorry, you can concatenate a tuple to a list. Okay, so that's also gonna work. Right? So and then the list will be. So you can go ahead and try these. Now you can use a list function. So there is a function called list. This will take any sequence, any iterable object, and it will turn it into a list. So here is this example, generator to list example. So remember we talked about this generator before. So let's take a look at this generator to list example. So let me expand the screen. So what we have is we have this isPrime function. So it checks to see if a variable is a prime. And then you read through this, and there is a prime sequence with begin and end. It basically creates a sequence of prime numbers. Okay. So here is the keyword yield to show that this is a sequence. What we can do is actually we can take it and turn it into a list. We can actually create prime numbers as a sequence from 20 to 50. This will be a sequence, but we can turn it into a list function. Okay. So if you run this, you actually see that these are the prime numbers from 20 to 50. Okay. So but it's in a list format. Right, if you try to print this itself, so let me print this portion. So let's see what we get. All right, so go ahead and okay. So notice it prints generator object, prime sequence, and here is the memory location. So it's the memory location of this object. So it's a generator object, but you cannot access it like this. So you need to use this list function from generator to turn it into a list so that you can have access to each element. We can also create lists using what is called list comprehensions, and this will be useful when you're testing your, let's say, code. Let's say you have an algorithm, you want to test it on a list, and you can actually generate lists on the fly. So these are called in Python list comprehensions. So we can actually have a range and turn it into a list. Here are some examples. Or we can comprehend with a function. Okay. So here is the same thing. What we are trying to do is we are trying to find the square values here. I'm talking about this one for all elements in this list. So we have a list and which is basically 0 all the way till 7. So we want to find the square roots of those. So what we can do is actually instead of looping through using for loops, so you can always do this with a for loop, right? So take a list and create another list based on that. But you can do it with a list comprehension. So what list comprehension does is the following. So you basically have a function. So here is the function. Any function that uses the values. And here is the variable. For now, I'm going to say variable, but actually this is variables. You can actually have multiple variables in the list comprehension as well. And here is set of values. All right, or ranges. So ranges for your variables. Okay. So this is how you can actually take a list, which is a collection, and then you can comprehend it any way you like. So what you can do is you can actually comprehend it to have a sublist. So instead of that function, you can actually have a condition. So that means take x for, so what this does is says take x if type is not equal to string. So that means take anything that's not a string. Here, take anything that's a string. Okay. So you can actually take this collection and take subset of that collection and create new lists. So this is what is powerful about using list comprehensions, and you will do this a lot. Now, some of the libraries like Pandas library has this function, has the functionality already built in. So you don't have to really do this directly. So you can actually use the library and then put conditions, and based on those conditions, actually it will pick the values from a given column. So data frames, as we'll see later, allow you to do that. But you need to understand this concept so that you can understand how to use those functions that are available in those libraries. Right, so this is relatively simple. I want you to just copy and paste these and try. So I'm gonna, in the interest of time, I'm gonna go through these, but you can try them. I may have some of them already in the file, so I'm gonna see if I can run them. So you can do a new list. So here's a new list you define, squares, and using a list comprehension. Okay. You can have pairs. So here is a 2 pairs. So what you're doing is you're creating pairs of x and y using whatever those values are. So what it does is basically for all x and for y in these two lists, it actually creates all the pairs for you. Okay. So you can do the points, you can do all kinds of things with this. Okay, here are some examples of these list comprehensions. So let's go ahead and do some of this. All right, so let me see. I may actually have them. So let's take a look at them. All right, here is a list, a couple of these comprehensions. Let's see if I have more. All right, I think this is it. So I'm creating a L, right? So in this case, what I'm doing is I'm checking anything in this range, all the way from 0 to 19. And as long as x is not in this list, so I'm actually removing these numbers from that list. So let's go ahead and print this. So this is my list, so the original list. Okay. The next thing I do is basically I go through this and iterate through the list. And this is how I do it. I create a list. This basically, doing this is equivalent to doing the whole list. Okay. So this part is equivalent to what this loop, this for loop does. So it's another way of doing this comprehension. So, but this single line, as you notice, is much more powerful, and you can do it any way you like. So instead of writing these 4 lines, you can actually write the whole thing in a single line. That's all there is to it in terms of list comprehension. Okay. You can also have max and min functions on the list. You'll see that they will work. 19 and 0 are the max and min elements in a list. Okay. This is also quite powerful. All right. So let's go back to the slideshow and take a look at this list. So what does this list do? So I have V, elements of 3 elements in this list V. And then I basically create all elements in V, and I create x and y pairs. Okay, so I have x and y pairs, both are coming from V. Okay, so I have basically 1, 1, 1, 2, 1, 3. I have 2, 1, 2, 3, and then I have 3, 3. Okay, so that's what that list does. Okay, and then I go ahead and find the pairs, but this time I want to make sure x and y are not equal to each other. Finally, I create pairs, and now I have my condition is basically I want to make sure the total of x and pi is not equal to 0. So this means they are not even. Okay. So as long as they are not even, I create pairs. So let's go ahead and do this. Actually, this is nice to run. I may have it in the code, but I'm just going to write it in the shell itself. Okay. So let's create the V. So let me get out of my way. All right. So here's my V. Any list. Again, I can create for x and y, I can create different lists as well. Okay, let's call these list points. So let's create the first one as a list comprehension where the x and y pairs, where x is coming for x in V and for y in V again. Okay, so they're both coming from the V, and then I'm going to have pairs. Okay, all right, so let's look at now points. You'll see now points will be all the pairs of x and y. So let me do this. Okay, so it's all possible pairs. Now out of this I can actually have a condition. So I can choose 2 points to be, and then where I can just say, and if x is not equal to y. So that's one option. Okay, so now when I do this and look at my points, you'll see it will eliminate the pairs where x and y are equal. So 1, 1 will go away, 2, 2, and 3, 3 will go away. Okay. The third option, I'm going to actually choose to say x plus y. I want it to be, and then where's my percent sign? All right. So I'm going to say equal to 0. Okay. All right. So or not equal to 0. Okay. So all right. So let's do this. All right. So let's go ahead and run this. Let's look at now points. So what it will do is it will take all the elements where x plus y is an even number and throw them out. Okay. So 1, 1 is even, 1, 2 is odd, 1, 3 even, 2, 1 odd, 2, 2 even, 2, 3 odd, 3, 1 even, 3, 2 odd, and 3, 3 even. Okay, so I'm left with 1, 2, 2, 1, 2, 3, and 3, 2. Okay, so as you can see, list comprehension is quite powerful, and you can actually create all kinds of lists. Okay, so if you want, you can actually do this: create a list and say. Actually, let me change this. I'm going to just go ahead and do it right here. So now I'm going to actually, so I can put any function here for x and y. Okay. So let's square them. Right. Right. So let's look at now points. You'll see now it will be squares of x and y pairs. Okay, where x and y does not add up to an even number. Alternatively, you can actually change the condition as well. So it's relatively simple. So you can actually go change the condition if you want. You can actually square them here too. Right? So that the squares are not add up to an even number. Okay. So, right. So it's quite a powerful way of doing creating the lists. Right. So we'll use them later, so you'll see them again. So in summary, you can actually have any list, and you can actually create a comprehension. As long as you have a list defined to be x for x in range. Okay, so this is the keyword. Okay, and then you can have only any condition with if. Okay. So uniform list, you can create a whole list using a single value. So basically a here. So let's look at this. Actually, it's better to look at just the file itself. Okay, so uniform list. This is make uniform list. Okay, so A is a list of 0, and then you're going to create 10 of them. So let's look at A. So if you run this, look at now what A becomes. A becomes a list of 10 zeros. Okay. You can do the same thing with a number. It doesn't have to be 0. You can set all the members of the list, initialize them equal to a float or a string is possible. Okay. You can have a whole list and then create a kind of a uniform list using that. So here the list is A is 10, 20, 30, and then I'm going to create a list of those. And you can actually have a collection and then take that collection and multiply. This will be quite useful later on when you're trying to do algorithms. You're trying to test values and create sample values for your algorithms. Now, the in operator, we have seen this already in many cases. I've shown your example. It can be used to find values in a list. And I think we have just done it in one of these examples right here. So here we are actually using this in keyword to check to see if the values are in this list. If they are, and then we just eliminate them using a not in operator. So in and not in and not in are very powerful operators for checking the elements of a list. Right, so here's an example list membership. So you can actually check to see, you can create one list and then you can look at another list and see if it is a member of the first list or not. So this is basically list membership. So let me close some of the files I've used already. So let me close this one. All right, so let me close this as well. So list membership, okay. So what this does is creates one list. So let's go ahead and print this list. I'm gonna go ahead and print LST, and then it creates a range. So this range. So I'm going to actually, what I'm going to do is, I cannot print the whole range. So what I have to do is change it into a list first and go ahead and print it. Okay. So I'm going to print this. So let's print those two. All right. So let's go through this. So this is my the list LST, and here is the elements of the second range. Okay, so what I do is go through this range, okay, check to see if there are elements in this list or not. If there are an element, I say is a member of this list, otherwise I say is not a member. Okay, so this is what I do. Okay, right, so that's all that does it. So each element, it checks to see if it's in the list, in the first list or not. Okay, so you can actually compare two lists very easily with this. The next set of topics are accessing parts of the list. You can actually create a slice of the list, and the slice is relatively simple. You just have a start, end, and step. Just like range function, you can actually take a list and start from certain elements of this, and then you can take a portion. This makes it very easy. Of course, you don't want to be out of range, so when you have an end, make sure that you use length of the list so that you don't go out of bounds and have an index error. So here are some examples of slicing the list. Here is the list at the top, all the multiples of 10 up to 120, and then you can actually have the list and then slice it. So what is interesting here is you can also slice this with negative numbers. Start from negative 100, go to till 3. Okay, so that's also possible, and you can do it in the reverse order as well. Here's that reverse order. You start from the second element, go to the -2. So it starts from the second element, which is 30. Right, and then it goes till the -2. What is -2? -1, -2. Okay, so that's an increments of 2. So it takes this element. So hold on, let's start this one. So it starts from the second element, which is this, takes 50, takes 70, takes 90. Okay, and then takes 110, and this is where it stops. Okay, so here is that example, right? This one, right? So you can actually have that as well. So slicing is quite useful, and there are many ways of doing this. You can actually take the whole list and reverse it with slicing as well. Here's another example. So if you don't have put values, then it takes the first element and goes all the way to the end of the list, and then this basically allows you kind of reverse the list in the traverse. So what this does is exactly like what reversed function does. Okay, so it just prints the list, right? It doesn't change the list itself. So the list functions, append is a function that it can attend, and then you can also find the index. So index of an element is basically the list and returns. Remember, it returns the first element, so that's the key. So when I say, let's say I have a list ABC, and let's say 5, and I have ABC again. Okay, so if I say find the index of ABC, so what it will do is it will give me 0, okay, because it's the first element. Okay, right? If the item is not in the list, remember it raises an error. So this is critical. You have to check the membership first before actually you invoke this index function. Check to see if it's in the list, and then you can actually do this. Other methods, there are insert, sort, remove an item, and reverse. So we have seen some of them, and rest of the other ones are relatively simple. So you can index at a specific, take this item and insert into a specific location. Okay. Those are quite useful functions. Explanations of these functions are here. I'm going to skip them. They're relatively simple. I think you can just run through this by yourself. There's a delete statement, and there is a min and max. So you can actually remove an element from a list. You can do that, and you can also look at min and max function. So this min and max can have sequence as an argument, and we have seen this when we look at the max function. So the max function, if you look at, go to your Wing and go click on help and max function or min function, you'll see that it takes any iterable object. So that means it can actually take a list as well. Okay, so it can take arguments, or it can take an iterable object. Okay, so that's the key. So when you use this, there's a difference between assignment and alias. So when you create two lists like this, A and B, okay, so these are two different objects. That means, remember this, these are two different objects. So there are two different objects in the memory. So then you go ahead and set one of them. You notice it's not going to change the other. However, when you use and assign B to A, so what happens is now A and B are the same object. Alright, so since they are the same object, when you assign one of them change, and the other one will change as well. Okay, so be careful about this as well. Okay, so let's go ahead and do this and show you quickly. Let me go ahead and restart, clear the shelf. Alright, so I'm going to go ahead and create A. Alright, so I'm going to have this, doesn't matter what I say, just to make sure it's the same thing. Okay, alright, and I'll go ahead and say B. And go ahead and then change value equal to 35. Okay, so now if you look at A and look at B, you'll see B will be the only one that will change. If you did this, if you just say A is equal to this and say B is equal to A, right? So now if you go ahead and change, you'll see now if you print A, you see A will change B, so you notice both of these have changed already. Okay, so this is the critical. So depending on what you're trying to do, either create copied lists or just make sure that you assign them to the same object. Okay, so you can think about this and use whatever you want to do, but use them properly. So that means when you're trying to copy lists, actually you can actually create a function so it can copy each element of the list. Okay, so you can create a list function that will allow you to do this and create a new list and return this. Okay, so this basically creates a new list and then returns that list, and each time you go item by item. But this is also dangerous because this is not a deep copy. This is called a shallow copy. Right? Because your list may have maybe a list of lists, so it just goes one level. So if you have a list and each element is a list itself, okay, and this will still be a shallow copy. Okay, right? So be careful about this. If you want a deep copy, that means you have to go in each element internally and copy each element. Okay, so you have to go not only copy this, but go copy this, copy that, copy this and that. So all those four values. Okay, there's a difference between this. So look at shallow copy and deep copy. So alternative is versus deep copy. I cannot write. Right. Jesus. Here we go. Right, deep copy versus shallow copy. Now, you can use list elements in calculations, numeric values, you can use them into a loop. So especially in your assignments, this is what you should do. Do not collect the values inside the list, like total amount to be ordered. You can actually do that using processing the list. Okay. And the list can be passed an argument to a function. So the print function, and I have an example of this in your slides. So you can actually have a list and print this. Okay, so you can do this, or you can create your own list. You can create a print list function and pass it the list if you want that print to be different. For instance, in your assignment, I want you to print first row as the column headings and then the values. So in that case, you want to create your own print function. Two-dimensional lists, just like Java, they work, so you can use it the same way. You can nested loops like this. So this is how they work. So if I have this two-dimensional matrix, what I'm doing is internally is I'm creating, first I have this memory location, right, of 4 rows. For each row, then I have one memory location. So this is the first element. So basically what this does is this is a list of lists. So this is the first list, second list, third list, and fourth list. Okay. So each row is a list internally. Okay. Right. So you can access them using indexes, just like you do with arrays. You can actually have scores 0, 0. Alternatively, you can loop through the whole thing as well. Okay. Now, final thing I want to talk about here is lists versus generators. So the difference is very straightforward. So generators give you all elements in one at a time, and they can only be accessed, traversed through forward iteration. The lists, however, allow you to access them randomly. You can have random access to each element of the list, and you can actually also do backward and forward and backward traversal. Okay? And so those are the differences. But you can always use the function called list function and turn a generator into a list so that you can do also a random access on the list as well. All right, so let's look at a few other examples here. So let me see. Let me close this. All right, so you can check the membership. We talked about that. So let me just see. I don't want to save that. Okay. All right, the final thing I want to talk about is called unpacking. So what you can actually have an element like this. This is called this is a tuple. So let me put a comment here and say, all right. So this is a tuple. So x is a tuple, and what I can do is I can take these elements of x and assign them to these 1, 2, 3, whatever, 5 variables. And if there is the last element, I can actually throw it away. So it's called a throw away variable, right? Underscore. So I basically take x and unpack its values to these variables, okay? And then go ahead and print. And then I can go also, so let's run this. So you'll see now it's going to go ahead and unpack each element. So all of these will be now into these variables, brand, name. So this is what I'm printing, right? Okay. Now, I can also have A and B as two lists, and I can define to be a new maximum, so max set. I can actually take all the elements of sets X and Y, okay, set their first element to the maximum of the two elements, okay? So what now happens is if I have 10 and 10 and 10 and 20, so now both elements will be set, the first elements will be set the maximum of the two. In this case, they are the same. So let's change them. So this is 5 and this is 10. You notice in the result, they're both set. First elements are set equal to 10 in both cases, right? So this is what it does. 5 and 10 finds the maximum and then sets both elements to 0, okay? So it's another function. And you can also traverse the strings using the for loop. And as an example, you can traverse the whole thing and you can write them each letter in a separate line. Hello everyone, right? So that's that example. So let me see if there's anything else. So we did this, okay, and I think that's it. This is it. I think I've done everything about this. All right, so this is all. I'm going to talk to you next time about classes and objects.